Hi, welcome to this crash course on database, and my focus will be on MySQL. So, what exactly is a database? A database is defined as a collection of data specifically arranged for rapid search and retrieval from a computer. Now, basically, um, I would I could just start with this definition, but let me track back so you understand why we need databases and what exactly are they. If you have a computer, remember the definition we used to say when we were still children back then in primary school. You said a computer is a data processing machine, which means that everything that concerns a computer or a electronic device is data. It's use and transformation of data. Now, data has to come from somewhere. In most cases, data can come from the input of the user. But sometimes you want the system to provide its own data or save the data that have been processed or the user just gave for easier use. Now, there are many ways the computer handles this, and this whole concept is what we call memory. One of such is, of course, the registers. When you see, I wish I have a diagram here, but if you have a small microcontroller system, the processor itself needs data to operate. And the way it gets data is through registers. This is a very microscopic level, and it's for people who want to go into learning and the rest that might need to know how registers work and the rest of that. Going upwards, you have what we call cache memory. Cache memory are just temporal memories that work for registers. Then you still have another layer called your RAM. RAM, you of course you know what your RAM is, aka also known as memory itself. It's another place where data can be stored for easier retrieval for the processor. If you look at the process or the pattern that we are going forward now, you notice that we are getting away from the processor. And the more we are getting away from the processor, the slower it becomes for data to be retrieved and started. Um, as we are going away from it. Now, when you go far away, you then have the disks. Outside the memory, you have the disks, which can be an SSD, an HD, or even sometimes an external computer. Now, the disk on its own is the slowest of them all, but kind of the most popular way of storing data, right? Now, this is where database come in. Database, in terms of your application, is a place where you store data for your software to run. Any data that you want to be persistent, that you want to come back and meet. Maybe when the server goes down, anything goes down, you want that data to be persistent. You save it most likely in a database. Now, database is not the only way you store data in a web application or in any solution. There are other ways you can store data, like the file system, mail, and the rest. A collection of all these ways of storing data is known as the data store, right? And the database is just a subset of the data store. Data stores are very critical for web development. So, and let's just try to expatiate the kind of different types of database that we have out there. So what are the types of database? Now, I could approach this topic by talking about all the different kinds of database, because I remember when we were in school, when you're talking about database, you talk about centralized database, decentralized database, distributed database, object-oriented database, blah, blah, blah. And this doesn't do justice to the conversation. I think that one, it's more, because it doesn't give you an idea of the different types of database out there. It just gives you different way by which I can use or work with a database. For instance, let's take a distributed database. I can make my SQL database distributed or centralized if I want to. I can make my SQL database talk to another centralized MySQL database. That means my own SQL database might be distributed to its own system. It's working for its own self, right? So the whole concept is you can make any of these database paradigms work as any of the so-called, because if you go online and search types of databases, you won't see this list I just made up. You will see more of the list I just said. Like you'll be hearing things like um, uh, um, distributed, centralized, object-oriented, blah, blah, blah. So let's talk about the list I created. The first type of databases that you might get, because I want to take it from the easiest to we go to the hardest. The first one you will likely get to meet is a key value database. You might have heard about Redis before. This is one of the most popular types of database that takes this approach to the database. Now, a key value database, the way Redis works is that you have uh, objects that are similar to a JavaScript object or dictionary. So they are saved in a key value database. Another perfect example could be your local storage. When you look at how your local storage works, they work similar to a Redis database. The Redis database are mostly stored in the system memory. So similar to more like a cache memory. So what that means is that Redis database are extremely fast because they are not on the hard disk. Because if they are on the hard disk or on the disk, you have to then consider read and write time, which can delay your application. But in this case, they are not on the hard disk, making them extremely faster. But the problem is their size, because of RAMs are not that large. Sometimes you get 16 gig of RAM, 8 gig of RAM, and things are already running on the RAM. Compared to an hard disk that can be 1 terabyte, 500 gig, um, 10 terabytes, so on and so forth. So hard disks tend to be larger compared to RAM. So you are limited. Most applications that use this kind of database, most times they use it for, they use it just to as an upper layer to more of these other databases that we are going to be talking about, which might be slower but are much robust than a key value based database. The next database we'll talk about is the wide column database. A very popular example is Cassandra. I hope you've heard of all these databases I'm listing, or you can at your own time go and check them up yourself. But I digress. Anyway, Cassandra or a wide column database is an upgrade to the key value based database. They do kind of try to resemble a MySQL database or relational database in the sense that they try to emulate rows and columns. Yet they still don't have a schema, but they do provide a querying language similar to SQL Server known as SQL. Now, a more popular type of database is document-based database. Everybody in this group should have heard about it. It's also a popular example is MongoDB, very popular. This model of database, you have documents which can be broken down to collections, which then can be broken down to a key value pair relationship. So you have something like a couple of JavaScript objects bunched together into a collection that is bunched together into a document. Now you are able to provide some kind of hierarchy, which makes you show some kind of relationship, but this DB is not really relationship first in its way, making it very limited when you want to do very advanced relationship or emulate real life relationship or softwares in our life. For instance, you want to do a inventory-based system, and you want to share the relationship between users, the goods, and their purchases. That relationship, in terms of its schema or its backbone, might not be visible yet. But in the next kind of database that we'll be talking about, the relational database, it's easier to show those kind of relationships because this database has a schema and a structure and also a querying language. This relational database, one of the most popular database category is MySQL, is one of the oldest and the most battle-tested programming paradigm, database paradigm you have out there. It's schemaful, it's structural, and it has a querying language that follows it, known as SQL. This makes it very good for BI, and it's highly secured, highly structural, and this is why many banks and financial organizations will always take a relational database first above the rest. I'm trying to run through the remaining of because I know my time for an introduction course is already fast spent. So next in line, we'll talk about the graph-based database. One of the limitations of a relational database, if you've ever used an relational database, is when you're doing a many-to-many relationship. And that's because when you are trying to do a many-to-many relationship, you might need a middle table. And if you've ever used some of these bridging solutions such as Sequelizer or entity framework in .NET, you will find out that it gets complex because of the way they are trying to handle this problem. It gets complex when you generate a DB model. I have had that problem when it comes to entity framework. But when you are using a framework such as, sorry, a database paradigm such as GraphQL, you don't have this issue because data relationship is being designed in a graph-based system. Now, please note, it's not like you don't have, when I'm saying a graph, it's not a graph board or a graph book. I'm talking about a graph. And if anybody has done mathematics here or computer science and probably engineering or statistics and the rest, you know what a graph is. The graphs are just circles with lines going out of it, right? So the circles are known as nodes and the lines going out of it are known as edges. Now, in a graph-based database, the relationship are known as those edges, while your data is known as that node, which makes it easy to do very, very advanced and complicated relational. Crazy, the term I use in this write-up is crazy relationship. So the next relationship, the next database paradigm is known as the search database. And one of its popular implementation is the Elastic database. It's mostly used for search engines because of how fast because of the way it handles and search. When you submit a query into the DB, it doesn't just save the query down. It also provides an index. When you provide an index, it makes it easy, just like an index in a book. So it keeps an index somewhere, making it easy that when someone writes something, it can quickly use the index to know where it's located. So it's not searching the actual data, but searching the index, making it fast to make queries, make reads from the database, which make it very, very useful when you are making all this, like if you use YouTube and you are searching and immediately you are searching something, you are seeing a response so quickly. YouTube, Google, and the rest, they use this search-based database to provide this kind of functionality. Now, one of the most amazing and the most unique in this paradigm that we're going to talk about, this paradigm list that we're going to talk about, is the multi-model database. As the word says, it's multi-model, meaning a combination of all of these models we've been talking about, or paradigms that we're talking about. And one of the implementation is FUNA. Now, in FUNA database, all you need to do is describe how your data is or how you want to retrieve it. One such language you can use for doing that is GraphQL. You upload your GraphQL code to FUNA, and FUNA will design your schema for you and apply any one of these paradigms as it's required in your code. So when you write it in GraphQL, FUNA can say, okay, the best implementation for what this guy wants is going to be a relational database or a graph database. Maybe I will use a search database, or maybe I just use a document-based database. GraphQL does all that overlifting, uplifting for you, or overlifting for you, or whatever. And all you just need to do is communicate with GraphQL. And the way you communicate with FUNA, with a FUNA DB, you use a similar model like the document-based model to communicate with it. So you are sending something similar to a database object, which is similar to JSON. So it's much easier. But the way the database is going to handle it is none of your business, because it could use any of the approved variables to handle it, store it, or work with it. So I hope I have interested you so far with my short speech. I know it's not short in any way. But in our next video, we'll talk about installing, because we said we are going to specialize on MySQL. And we are going to talk about installing MySQL and MongoDB. Then next up, we will then look for how we would communicate with those DB and write codes for those database.